Hello there. Today I want us to talk about the half-life. So half-life is the time taken for half of unstable nuclei to decay. So that is half-life. Half-life is the time taken for half of the unstable nuclei to decay. So that is half-life. Now let's look at some of the examples. Example 1. We run through certain examples. So an example here we can say there is 40 grams. So there is 40 grams of red jam. There are 40 grams of red jam. That has the half-life of 1600 years. Okay. Question number 1. How many grams are remained after 6400 years? 6400 years. Well, solution. So what we are supposed to do now is as follows. We need to understand that the half-life is the time taken for half of the unstable nuclei to decay. And in this case, this nuclei here, the nuclei of radium, is not stable, it is unstable. So what we are supposed to do is now to calculate and show how many grams remained after 64 years. Now, what you are supposed to do is you need to draw a table. Okay? You need to draw a table. So I have drawn a table of two rows. So in here I'm going to write, because we have got just two quantities, I'm going to write one quantity which is time measured in years. Then we also need to know that there is mass which is being measured in grams. So the next step that we are going to take is the initial quantities. And the initial quantities for time is 0. No time begins at 2 or 3. It always begins at 0. So here now we need to write the total mass of radium. Which is 40 grams. Is 40 grams. Then in the next box, that's now where you do the following. You need to add the half-life of radium, which is 1600 years. So we're going to say 0 plus 1600 years. The answer you will find is 1600 years. And then in the first 1600 years, how much or how many grams of radium were decayed? So now we're going to divide, because we are talking about half-life, which means half of this 40 grams. It is the one that we are writing here, which is 20 grams. Another 16, another next 16 years, meaning you are going to add 16 plus 16, which gives you 3200 years. In the next 3200 years, how much, how many grams of radium remained? We find that half of 20, you just need to divide by 2. The answer is supposed to be 10 grams. And then after this, which is now going to be 4,800 years, when you add 32 plus 16, which is the half-life there, it is going to give you 4,800. Half of 10, that gives you 5. Now, again, there you are going now to ask yourself to say 4,800 years. Then 48 plus 16, the answer you will get is supposed to be 6,400 years. And then half of this number here, which is 5, it is going to be 2.5 grams. The question says, how many grams are remained after 6,400 years? So our answer for now that we are supposed to get, we need to know that the answer is supposed to be this, which is 2.5. So under the answer there we can say 2.5 grams over radium remained. 2.5 grams of radium remained. Now, one thing that you should also consider is as follows. As the time increases, the grams are also decreasing. As time increases, the mass of radium is decreasing. That is one thing that you are supposed to know. And the other thing is, whenever time, how is time increasing? Time is increasing by adding half-life after half-life. And the more you add half-life after half-life, the half of the total number of mass is also decreasing. So it's going like this. As time goes up, the mass goes down. So this is how it is moving. Okay? In this direction, different directions. Let's look at the other question, which is B. Question B says, if 5 grams of radium, 5 grams of radium remained or are remained, how long does it take? How long does it take? So how long does it take? Here we are looking for time. How long? That's the keyword. How long? That is the keyword. How long does it take? So what are you going to do now? What we're going to do in this case is just go back to your table and check where is 5. 5 is here. Check what is up there. Just like here we check what was down. So here now we are checking what is up there. It is 4,800 years. So the answer to B is 4,800 years. 4,800 years. That is how long it took for 5 grams of radium to decay or to remain. Now, at this moment, we have to draw a diagram to show a curved diagram. So how does that come in? We are going to come to question C. So under question C says draw a decay curve to represent the information. So So we are going to draw a curve. Draw a curved or a decay curve, sorry. Decay curve. So how do you draw a decay curve? The first thing that you are supposed to consider is come up with the table of values. So I am going to draw this table of values here. So under table, make sure you write table of values. Very, very important because it helps you to plot the coordinates or the points very well without problems. So we need to understand that in order to do this, there is what we call the X or Y plane. That's what we are going to use. So in the X-axis, and then we have in the X-axis we have what we are calling time. Time is supposed to be in the X-axis in years, while the other one, which is mass, it is supposed to be in the Y-axis in grams. So the next thing that we are going to do now is we need to just copy what is here and then transfer it. So we have 0, we have 40, we have 1600, we have 20, we have 32, we have 10, we have 48, we have 5, we have 64, and then we have 2.5. Now, we need now to bring down what we are calling the y-axis, which is here. This is the y-axis. So that y-axis, and then you write, you're going to write this is mass in what? Grams, and this is time in years. Time in years. If you want, you can write it somewhere here, but due to the space. Now, you need to understand that for a very brilliant drawing, okay, graph, you are supposed to use the scale. Okay, so in this case, I'm just going, since this is a board, I'm going to make sure that this side in the y-axis, 1 centimeter is equal to 10 units. 10 units. So that's what I'm going to do. So here we have 0, and then we have 0 here, then we have 10, we have 10, we have 20, we have 30, we have 40. Then down here, I'm going to begin, we just try to say we have 1600, then we have 3200, then here we have 4800, and then lastly we have 6400. So once we do this, we need now to come up with the points. We plot the points. So here we have in the y-axis, in the x-axis, we have 0, so it will be 0, 40. So this is where the 40 is, and then we circle it. Then we have 16, which is down here, 20. So 16, 20, which is supposed to come here, and then the dotted line. Make sure that it is a dotted line, and then this is where the point will be, the next point. Then the other point is 32 against 10, so it is going to go like this, and then the points goes down like that. Then 48 against 5, so half of 10, that gives us 5. So 5, that means we go in this direction, we go this direction. If you are using a graph, make sure that your practice is supposed to make sure that it's 5. And then we have 2.5, which comes now half of 5, that is 2.5. So assume this is the 2.5. So this is how the graph will be. Now we need to plot it. Plotting it, you need to make sure that it joins, you join all the points. So there I go. Wow, nice here. Very good. So how to finish it? You are now going to say a graph of curved line. A graph of curved line. Well, you need to make sure that you practice all the steps. You need to follow the steps that you need to do. I mean, all the steps that I have demonstrated, and also make sure that you practice, because practicing these questions makes it very possible and perfect. So this is how you can find the different questions under half-life. I wish that um, you learned and also I wish that or I hope you have learned and enjoyed the lesson, and make sure that next time when I do certain questions, you should have been familiarized yourselves with this example so that you don't have problems in the next video. Thank you for watching, and stay blessed until next time when I bring you another exciting video containing the other part or the other method apart from graphical method or curved decay method. I will bring now the other method which you are going to enjoy.